Hi kids, Mr. Payne here. Today we're going to be talking about osmosis a little bit more. Now we've just introduced this topic just a little bit in my class and Mr. Anderson's class. Today we're going to start to look at an investigation looking at how osmosis actually works. So hopefully you'll get a chance to see it in action over the course of this video, which will take me a few days. We would normally do this in class. I'm going to do the best I can to show you it right now, but I'm also going to walk you through it so that if you want to, if you are able to, you can do this at home and perform this investigation yourselves. Alright guys, so what is osmosis? Check it out right here. Check out that. Hopefully it'll be an animation, maybe it'll just be a picture, who knows? But what osmosis is the movement of water through a membrane, like a cell membrane, like that outer covering of the cell. The water moves from an area of high concentration where there's more water to an area of low concentration where there's less water. Now, as we can see in the picture slash animation slash who knows what's floating over my shoulder right now, even though the water level may seem the same, like it's starting out the same, if we have one side of the membrane that is filled up with sugar or something else dissolved in the water, there'll be less water in that area than over here that has nothing dissolved in it, pure water. So keep that in mind though, even though it may seem like it's the same level of water, if there's stuff mixed in it, like sugar, then there won't be as much water there. In this lab, I'm actually going to be able to show you real cells absorbing or losing water depending on the situation that they're in. They'll actually be undergoing osmosis. Water will either leave the cell or go into the cell depending on the situation. And I'll actually be able to show you that in such a way where you can see it with your own eyes. There won't be any microscopes involved. Most cells are super small. They're microscopic. We can only see them with a microscope, not with our eyes. But there are a few exceptions where we can find a single cell that is large enough to hold and to look at. Can you think of any examples of a single cell would be big enough to hold and see with your own eyes, maybe even eat? If you guessed eggs, then you are correct. The egg from a chicken, or any other bird or animal for that matter, is a single cell. That egg from a female chicken is an unfertilized egg cell. And then if it's fertilized, that cell will divide and multiply and become many cells, which will eventually be a chicken. But if we start with unfertilized eggs, like you can get at the supermarket or from your local chicken, if you can find one, then that's just one single cell. All right, that's what we're going to take a look at. But that means we need to get some eggs. Let's go get some eggs.
Okay, got my eggs. Thanks, buddy. Let's head back inside.
We have the eggs. Now we're back in the lab. Okay, it's my kitchen, but in these times we kind of have to make do with what we have, right? All right, you'll probably do it in your kitchen too. So I have my 2 eggs, and like I said, these are cells. These are a single individual cell, and rarely do we get a chance to have individual cells that are this big. It makes them easy to study, which is nice. So we have 2 eggs. You'll see why as we move through this. I have labels here, egg 1, egg 2. This is Eggwardo. And this is Egmund Freud. Come up with funny names, whatever. I'm not that creative. That was the best I could do. Sorry. So in order to differentiate them, to tell them apart, we have these labels. I'm going to put these labels on these containers. So you need some sort of container for your eggs, something that will hold liquid and that the eggs can fit in. So I just have some little glass jars here. You could use plastic cups, you could use whatever, you know, just don't use your nice cups. I don't want your mom yelling at you because you're putting raw eggs in her nice cups. But whatever you can find, 2 separate containers that you put your eggs in. And I also have a scale right here. Now this part is what we would do in class. You may not have a scale on hand. It's okay. You can still do this lab without the scale. So we need to start off with our empty container that the egg is going to go in. That has to go on our scale because that container has mass. It has a weight to it, 162 grams to be precise. So this button right here is if you do happen to have a scale, it's called tare. If we hit that button, it brings it to 0. So basically the scale is not counting the weight, the mass of that glass container. So now I can put the egg in it, Eggwardo. And it goes gently, hopefully, and then on. And now it's recording a mass, a weight of 59 grams. So I'm going to write that down. Day 1, on in here. Check this out. Day 1, 59, oops, I can't write very well, 59 grams, okay? Now I'm going to do the exact same thing for egg 2, Eggman-Freud. All right, so same thing. Need to make sure that that's set to 0. It is. Then I can put egg 2, Eggman-Freud in there. He is at 61 grams. So again, I'm going to put day 1. Day 1 and 61 grams. Okay? This is the first day of a 3-day lab. Let's get that egg back out. Okay, so like I said, these are individual cells, and just like the tiny little microscopic cells that we've been studying, they are surrounded by what basically is a cell membrane. It's technically called a shell membrane, but it's a membrane that surrounds the contents of the egg, and it does allow stuff in and out. Oxygen, carbon dioxide, water, as we will see. But the problem is there's something on top of that cell membrane or shell membrane, a hard eggshell. The eggshell is made of mostly calcium and also some carbon dioxide. Calcium carbonate is what makes up this eggshell. In order to do our experiment, we have to get rid of these eggshells. But we have to get rid of these eggshells without destroying the eggs, without breaking this cell membrane, so that everything stays intact. We basically want a soft egg at the end of this. So think a little bit, how are we going to remove these hard shells with materials that we could find at home? Let's think about that for a second. Did anyone say vinegar? Because that's what we're going to use. Vinegar is actually a type of acid, acetic acid to be precise. And the acid that makes up vinegar will actually be used to dissolve the eggshell. The acetic acid of the vinegar will combine with the calcium carbonate of the eggshell, and it will break it apart. It'll break it apart into its 2 main parts, calcium and carbon dioxide. So, take a look. All I'm going to do is fill in enough vinegar so that it just barely covers the egg. And your egg may float a little bit, and that's okay. So just until it starts to float or until the egg is completely covered. The amount is not terribly important. As right away we can see the chemical reaction taking place. All those bubbles that you see, that's carbon dioxide. Remember, like I said, the eggshell is made of calcium carbonate, which is calcium, which is really good for your bones and teeth, and is a very healthy nutrient, and it gives the eggshell its structure, its strength, but it's also combined with CO2. And when it breaks apart, that's released as carbon dioxide gas, and that's what those bubbles are that you're seeing. So we're going to let that go, and we're going to leave that overnight. Now, usually I would give that about 24 hours because we would have class one day at a certain time. We'd let it sit for a day and then come back to it 24 hours later. So sometime tomorrow, I'm going to come back and start this up again, and I'll show you what our result will be. Stay tuned.